Let's do another example. So let's say f of x is x squared minus 3x minus 4. And we'll say the other linear function is 4x minus 4. And I want to know what's the solution to the system. So what we're going to do is we're going to say that we want to know when f of x and g of x are equal to each other. So we want to know when x squared minus 3x minus 4 is equal to 4x minus 4. It's a quadratic system. We have to get a 0 over there. So we're going to have x squared minus 3x. The 4 goes to this side, becomes minus 4x minus 4. The negative 4 goes to this side and becomes plus 4. And now that's equal to 0. So overall, that's going to give us x squared minus 7x equals 0. And there's going to be two solutions there. There's going to be two solutions to that one. So I could factor this one again. X times x minus 7 equals 0. So x equals 0 or x equals 7. And plugging that back into that one over there. So those are the answers we have. So if x equals 0, I probably should not use that color again. If x equals 0, then g of x, which is going to be the same thing as f of x, is going to be 4 times 0 minus 4, which is going to be negative 4. And if x equals 7, then g of x is going to be equal to, or I should have said g of 7, is going to be equal to 4 times 7 minus 4, which is 28 minus 4, which is equal to 24. And so the points of intersection are going to be, from the top one, x is 0, y is negative 4, x is 7, y equals 24. Or, to put it another way, we could say that f of 0 equals g of 0 and f of 7 equals g of 7. But either way, there's 2 points of intersection. Let's move on to example 3. So, let's go with a more consistent color scheme here. So let's say f of x equals x minus 3 squared plus 7, and g of x equals minus 4x plus 15. And it's still a quadratic, nothing too special there. So we want to know when is f of x equal to g of x. So what have we got? F of x is x minus 3 squared plus 7 equals negative 4x plus 15. Just because it's non-standard form doesn't mean we're still going to have to, so we're going to expand this thing. X minus 3 squared is x squared minus 6x plus 9 plus 7 is minus 4x plus 15. Bring this to the other side. X squared minus 6x minus 4 becomes plus 4, plus 9 plus 7. 15 goes to the other side, becomes minus 15. And then we collect like terms. Minus 6 plus 4 is minus 2. And 16 minus 15 is 1. So let's say we don't know how to solve this. So this actually factors pretty easy. But let's pretend that we didn't actually know how to factor it. Let me grab a piece of paper. So if I didn't know how to factor this, then what I would say is, so we have x squared minus 2x plus 1 equals 0. So the a is 1, the b is minus 2, the c is 1. We know that x is minus b plus or minus the square root of b squared minus 4ac all over 2a, which is, plugging things in, minus minus 2 is 2, plus or minus the square root of 2 squared, well, negative 2 squared, minus 4 times 1 times 1 over 2 times 1, which is going to be 2 plus or minus the square root of, that's 4 minus 4, oh, that's 0, over 2. And adding that actually gives us the same answer either way. So x is going to be equal to 2 over 2, and x equals 1. Now we actually could have figured that out another way. If we go back to this one over here, we could have said that this factors into x minus 1 squared equals 0, which means that x equals 1 is also the only solution. But notice there's only one solution here, right? So the solution is, we're going to figure out the actual solution. So the solution is going to be, we need to figure out, so we know that x equals 1, and then we want to figure out the y. And so we're going to use the easier one. I think that's going to be the g of x is minus 4 times 1 plus 15, which is minus 4 plus 15, which is 11. So the answer is, this intersects at 1 and 11, and that's it. That's the only point of intersection. So if we remember the three ways that these things could intersect each other, what we have is we have a situation like this, where we have the quadratic and we have the line, and they only intersect at one point. So what we have here is they only intersect at the one point. Okay, last example. So f of x equals x squared minus 6x plus 11. G of x equals negative 5x plus 4. And what we have is, we have f of x equals g of x. So x squared minus 6x plus 11 equals minus 5x plus 4. X squared minus 6x plus 5x plus 11 minus 4 equals 0. X squared minus x plus 7 equals 0. I don't know how to factor that, so we're going to quadratic formula this thing. So we have x squared minus x plus 7 equals 0. So the quadratic formula is going to be x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Minus b is going to be minus minus 1, which is 1, plus or minus the square root of negative 1 squared minus 4 times 1 times 7. Ooh, we're going to have an issue here. Can you see what the issue is going to be? We're going to have 1 plus or minus the square root of 1 minus 28 over 2, which means that x equals 1 plus or minus the square root of negative 27. But that doesn't work. So there is actually, if we take the square root of negative 27, there is no real square root of negative 27. So there's no solution. So the solution to this system is actually that there is no solution. There's no value for x where f of x is equal to g of x. So if we go back to our three situations, it's going to be this one over here. The quadratic and the line, they never meet. There are no points of intersection. There are no solutions.